as we read through this, we're down here in part two, and we're talking about transforming the data. All right, so we need to put these additional variables in our data set, and we need to add them in the Excel file and fill out the table of information on them. So the first one is it says transforming data. We're going to create some new variables. So we're going to, these are mathematical transformations. So the first one is a percent change in spending between 2021 and 2020. So we're just going to call that, you can name it whatever you want. I'm going to name mine percent change. And you may wonder, why don't I put any space in my names? That's a carryover from older versions of Excel and older other software programs that didn't let you have variables that had spaces in them. It saves space also, so I kind of keep doing it. But so this is where we're going to write what the specific definition. We're going to have the percent change in spending in 2021 versus 2020. Right. And then I'm going to let you fill in what the, if it's categorical, numerical, and the scale of measurement, and if numerical units, what format. So this is a percent change. So I will tell you, this is just a percent is what we would put as the units here. I'm going to center this. Okay. And then the next one is a natural log of income to make the values more normally distributed. So that's a little bit of a result of me looking at the income data. So I'm over now in the clean data. I'm selecting the whole column that's income. I'm going up to insert, and I'm going to go to the middle to the charts. That's the histogram. And when I look at this histogram, I see that I have a right skewed histogram where I'm having more of I don't have a normal distribution. For one thing, I have this abnormally higher lumps here, and then I have this tail values here. So what I'm hoping when you see something that's not quite normal and we think it might be an essential part of our analysis is that we would like this to be more normally distributed. Hence, we're going to look at the natural log transformation of these income values. All right, so I'm going to delete this now because it was just to guide me to decide on making that variable. So going back to the variables, I'm going to call this LN income. And I'm just going to say this is the natural logarithm to be formal transformation. Maybe I should just say natural logarithm of income. I'll let you work out what that is. There are no units. Technically, you could say it's the log of dollars is the units, but that's generally, maybe we'll say NA, not applicable. And the next one is the age. So I'm going to say age. I'm just going to call it age. And I'm going to say age of customers on January 1st, 2022. Okay. And we know that the scale of measurement for that. All right, so then over here, we're going to come in and we're going to look at this binning request. So if you recall, Catherine Hill requested a RFM analysis. So we need to even understand what an RFM analysis is. Basically, you're going to get the quintiles of 3 variables. The R for recent. This is a marketing tool to find your best customers. And the idea is to find the best top 20% of your customers based on 3 criteria. R for recency, or how current are they, how recent have they been good customers. So we're going to use the days since last. And another characteristic for a good customer is the frequency. So how often are they shopping at our business? So we're going to use number of orders. And then also, how much money are they spending? So we'll use and that stands for monetary. And so we're going to look at the spending in the last year in our data, which is spending 2021. So each of these characteristics are going to get divided into quintiles. And then what we'll do is we're going to use the quintiles for each one of these and concatenate together a new variable, which is the RFM category. So we're going to concatenate those 3 bins. And for example, we're going to give each quintile a number. So like 2 is you're in the second quintile, 3 you're in the third quintile. And then we're going to concatenate those numbers from the R, F, and M and together create a variable. So for example, a 111 is someone who's in the first quintile for days since last, number of orders, and spending, because they're in the first quintile for all 3. Whereas someone who's a 123 is in the first quintile for days since last, the second quintile for number of orders, and the third quintile for spending. Once we go through this somewhat long process to create this RFM variable, then we'll delete all the parts, the R, the F, and the M quintiles, and just keep the RFM. And we can choose to keep it in keep the RF and M quintiles if we want in our one version of our data and not in the final analysis ready data set, because in the analysis ready data set, we generally don't include any variables that we don't feel are useful for the analysis, because if not, it kind of becomes too unwieldy, too wide. All right. We are also asked to bin income into 5 equal size bins. And we were also asked to provide a structure for a tiered membership based on 2021 spending. So I think for one of my sections, I gave some cutoffs, but I want to actually kind of roll that back a little and assume we don't know what to use. So we're going to determine the cutoffs of tiered membership based on the spending and assign customers as either being in a bronze category, silver category, or gold category. Okay, so as we go in here, let's go ahead and you're going to start converting this information over here to new variables. All right, so the first one is R, which I'm going to say R is the quintiles of days since last. And that is a categorical because it's going to be a bin name. And the values are going to be 1, 2, 3, 4, or 5. Okay, even though they're numbers, they're actually quintiles. Sorry. Even though they're numbers, actually, this is ordinal, isn't it? So they're categorical and with an ordinal scale of measurement. Okay. And then because every value, even the minimum, is going to be in one of these. So there's no real 0. So and we aren't going to be able to do any real math with these numbers. So that's part of the reason they're categorical and they are ordered. So we will say they're ordinal. You're going to do the same thing with the F and the M. All right, then we're going to get to RFM is going to be what we're going to create using that. And we're going to say this is the concatenation of R, F, and M. And I'll let you fill these out. The values are going to be 1, 1, 1, and you can kind of go through this. 1, 1, 2, sorry, 1, 1, 3, etc. Okay. Dot, 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 till we get to 555. All right, so you don't have to write out every single one. All right, the next one down was binning income into 5 equal size bins. So let's say bin income. And we'll say this is the quintiles of income. I'm going to say that we pushed back and we had a meeting with Catherine and we actually decided that what we want is to we want to do that. We recommended that quartiles would be better for this. So we're going to switch this to quartiles. All right. So that's a change on my part because I'm the professor and I can do that. Normally you wouldn't be able to do that. We'd have to have a meeting with Catherine. So we're going to do binning income into quartiles was requested. All right. So we're going to say bin income, and here we're going to change this to quartiles. Then the next thing is we need a structure to provide a tiered membership that the categories are going to be bronze, silver, or gold. So this was one where we may need to come back later after we put in the values and actually tweak this definition to cover what we need it to be. But for right now, let's just call it membership maybe. And we're going to say this is membership based on membership category based on spending 2021. And again, this is categorical and it is ordered, so it is ordinal, and it's going to be bronze, silver, and gold. And then we're going to have a couple more things that we need to add. We're going to add the category reduction. So I'm going to let you keep going on filling out this table with the category reduction. And also the dummy or indicator variables for the variable sex and the variable channel. Once you have that whole table filled out, so you're going to need to have something in here for female. You're going to have some dummy indicator variables for channel. And we're going to use web as a reference, but I know TV is another one. Standard mailer is what the SM stands for. So standard mailer. And you're going to put more information here. Standard mailer, dummy variable. Okay. I'm getting you started. All right, so on. So you kind of, etc. You got to add them all in here. Once you have everything in here, probably the easiest thing to do is now go ahead and open up my analysis plan for task 2. And this is where I was saying the following variables will be added. I am actually going to download this out of Google Docs because I know that Word has a lot of functionality in this area. So I'm going to go up here to File, Download to Word. There are some things that are fine to do in Google Docs and other things that are a little bit better to do in Word. So now that I've done this, I'm going to open that version of that in Word, but I want to make sure when I upload it back, I don't have an issue. So I want to go back to that tab that I had opened in our class project worksheet. I'm just going to close these out. Hey everyone, I'm going to put together this video as a brief touching base on doing the part 2 that's of the Excel work, task 1, part 2, as described in the analysis plan. So right here, I've opened up the part 1, task 1, part 1 Excel, where we have the clean data. And you should have this already. And if you are not matching my numbers or you're not 100% sure, you can pick up using mine, which is on the class project shared drive. So we have all these tabs, so I can right click on these and sorry, I tried to right click, there we go. So this is what we have so far. We have those listed in the analysis plan. So let's get that open. Okay, so these are the new variables that we're going to be adding. So I'm going to basically put these next to, so I'll have the analysis plan next to my Excel file. And I'm going to go back over to that clean data. And I want to make a copy of that. So I want to make sure I kind of protect, in a sense, or preserve this clean data that I've already made. I'm going to now be adding additional variables. So let's go ahead and just make a copy of that. So I right-clicked on the tab at the bottom. I'm going to click the box that says create a copy, and then I'm going to select move to the end. So we'll have that new one now. You can see the two. Now let's rename it. I'm going to call this data plus additional variables. And so now that we have this is where we're going to be adding additional variables on the right-hand side. So we're going to be adding in here, just looking over here at the list that I'm seeing in the analysis plan. I see percent change. And then I see the natural log of income. Then I see age. Then I see R and F and M. This is part of the RFM, the build for the RFM analysis. And then we have the income that we're going to bin in quartiles. So I'm going to call it income bin. You can call it whatever you called it in your analysis plan. It doesn't have to exactly match me as long as you've defined everything in your analysis plan and what you're going to call it. Then I have membership. And this is the one where we're not 100% sure yet what we're going to use for our cutoffs. I was going to see what you guys came up with. Some of you, if you're in my 2 p.m., the section 5, I did put out some initially. And then I sort of backpedaled and thought, you know what, it's a good idea to not have me spoon feed you that, but rather you think about what would make sense. And then we're going to create some race category reduction. Race red is what I called mine, but you can call it anything that you know what it means. And as long as it's in your analysis plan, once again, it is fine. So then I'm going to add female. That's going to be a dummy variable that I'm going to derive from sex, where male is the reference. And then I'm going to have several more dummy variables, all of these deriving from the categories in channel. So we're going to go to TV and SM and referral, with one F, and then other. And excuse me, I think we could possibly not confuse this other with other things. So I'm going to change this in the analysis plan. And this is fine. You can do stuff like this as you go. So this is other CH. So I just want to make sure that it's clear to me, since I'm going to be working with this, that other is not just some random other anything. It's other channel. Okay. So now I've put those all in here, and I pretty close to have them memorize what they mean, but you know, you can always refer to your analysis plan. And now we just need to add these in one at a time. So you can figure that out. So the percent change is in your notes, and I'll let you program that one. The natural log of income is equals ln. So remember, this is the one I had to give you the correction on the Excel file, that it is ln in Excel is for the natural log, And it's a natural log of income. So I'm just going to click on income, which is here on the same row, and close the parentheses, and I have the natural log of income. And now that I have that for that row, all I need to do is go ahead and double click that, and we will now have the natural log of all the values in income. The next one is age. And the age, if you recall, we can review that if you want. Let me just get back over there. Oops, I'm hitting the wrong button. Apologies. So let's review age from the analysis plan. So the age was the age as of the customers on January 1st, 2022. And if you recall, the data was, that's the day that the data was pulled from the computers at this company. So the function, and again, this is also in your notes. We went over this year when we were talking about data transformations, and I was showing you about converting dates. So this is done with year frac, and you can see it tells us the start date and the end date. So the start date is the birth date, and the end date is January 1st, 2022. And what I told you was we need to let Excel know that this is a date. And so to get Excel to understand the numbers that go in as a date, it's a good idea to use this function date. And you see it tells us the year, month, day. So we can say 2022, comma, January, we'll give it a 1. And then for day, we'll also give it a 1. So we'll close the date for that, and then we're going to close the year frac open parentheses for that function. And when we hit enter, we get that this person was 35 years old, 35.04 years old. And what we talked about in class is that people report their age, 35.04. They report their age usually without a decimal. People just say how many complete years they've lived. And what I told you is that there's a wrapper function that we can wrap all of this inside the function that will give us just the integer portion without rounding. So int, and then is the function, and then we just need that closing parentheses. And again, I'm just putting space here in the formula bar for emphasis. Excel will ignore space. I'm putting that there so that you are able to see it more clearly. Okay, so we see that this person is 35, and then we can just use this formula to get everybody's age. And I'm going to center that just because it makes it a little bit easier to read. All right, R, F, and M, these are the quintiles for each one of the different pieces of that. So if you recall, R is for the quintiles of days since last. And the way you're going to do that is you need to create a lookup table and use index match using the quintiles of days since last as the variable that you get quintiles for. And number of orders, we're going to get the quintiles of that. And we're going to get the quintiles for spending. So for each one of these, we're going to need to do a lookup table. So maybe what we need is a new sheet, and we'll call this additional var calculations, maybe calcs, or you can call it lookup tables or something. So this worksheet, we're going to just give it a little title. This worksheet contains lookup tables, just a little description of what we're doing, used to create new variables in the data. So the first one we're going to be doing is the quintiles of recency. So recency, if you recall, is going to be based on days since last. And if we now switch over so we can see our data side by side. Okay, so we want to do the quintiles of recency, and it's based on days since last. And if we go over here and we look at days since last, and it may take you a second to realize it, but the days since last is the number of days counting backwards. So we actually need to count this. We need to really get the reverse of this. So let's call recency, because we want to go in quintiles, and the larger the number under days since last, the more in the past it is. And we actually want to get quintiles of the more recent. So we're going to say recency, and we're going to say this is just equal to -1 times the days since last. Okay, and this will enable me to be able to get the more recent customers will be higher up. If you think about this as being temperature, the recency being the temperature, the warmer temperature, if you will, closer to now. So we want the quintiles of recency. So here we're just going to go ahead and put in our quintiles. And these quintiles are fifths in our data, and we're just going to name them by which fifth it is. So we'll just say 1, 2, 3, 4, and 5. And then we're going to need the bin min. So those quintiles are like our bin names. This is going to be bin min and then bin max. Okay. So for our bin min, for our quintiles, we can use the percentile function, percentile inclusive. And from that, we're going to get the recency column. And we'll get the 20th percentile as the 0.2 percentile. The 20th percentile is the first quintile. And if you look at days since last, we actually want to count this in whole numbers. So let's wrap this days since last recency. Let's round this. And I'm just going to put a (0) so I get the whole number out of this. Okay, and now we can copy this down for each of the quintiles. We might as well make this into a table with the window pane option. And now let's change each one of these quintiles. So the first quintile was the 20th percentile. The second quintile is the 40th percentile. The third quintile is the 60th percentile. So 0.6 is what I'm putting up here in my percentile as a decimal. The fourth quintile is the 80th percentile. And then the fifth quintile goes up to the maximum in my data, which I can put in as a 1. Okay, so we see that the most recent customer order was 6 days ago. That's what the -6 is telling us. Okay. In here, we can get the minimum in our data. And we'll see it was -360 days ago. And because we're counting in whole numbers, we know that we're going to go up to the previous bin's maximum and add 1 to it. That's our incremental change based on the precision of our data. So we're going to copy this down. Okay. And now that we've done that, and we have the quintiles in this data, we're going to use the same approach for the F and the M. Okay, and so now that we have those quintiles, we really don't need this recency variable anymore. And so we can actually get rid of it. If you look over here, we are depending on it. So again, this is a technique that is a fundamental technique in Excel. And you want to make sure you're really clear on it when you use it and when you don't. And it's one of the reasons people switch to R when they do an analytics. It's a little clunky, but we need to convert. If we're going to get rid of recency, we got to convert this data over here to actual numbers. So just once again, we're going to copy it. We're going to paste in the upper right corner the values themselves. So now if you click on any of these numbers, you'll see that it's no longer percentile that arrived at that. And now we can go over here and we can delete the column recency. And we can then proceed with our binning. Using index match to get R, F, and M. And once we have those three, we're going to come in here and we're going to concatenate. So we'll say equals concat. And we're just going to take whatever R is, whatever that turns out to be from our index match, whatever F turns out to be, and whatever M turns out to be. And these are going to get kind of glued together. And right now it's blank because they are blank, but that will be the function that will concatenate the R, F, and M quintiles to create the RFM for the RFM analysis. And if you recall, or if you think about it for a second, F being in the top 20% in each one of these three categories is considered the RFM analysis from a marketing point of view is considered these are your top 20% of your customers. So we actually would want to we may want to do analysis where we look at the 5 RFM customers. Okay. And then we're going to have income bin. This is another binning, right? So after we create our quintiles for days since last, we're going to be repeating this. So I can copy this. And we're going to repeat that, but we're going to change this to frequency. So will be number of orders. And then monetary for the M. So we're going to copy this. And here it'll be quintiles of spending 2021, right? And again, this should be all in your analysis plan. So we'll have these three lookup tables, and then we're going to need one for income. So this one is quartiles of income. And quartiles have, very distinct, so I'm going to just grab the top four of this, names, right? People always refer to them. They're very popular with the, Q1, Q2, Q3, and Q4. Okay, so those are going to be our quartiles. And I think we're going to want to change this to be quartile. Okay. And I'll let you work on that one again. Very similar, just reinforcing the skills on how you do these things. All right, the next one that we're going to talk about is membership. So membership was where we wanted to make a bronze, gold, silver, and gold. And we wanted to base that on, I believe it was spending, right? So let's just double check ourselves on that. So we have membership on spending in 2021 is what Catherine Hill asked us to do. And so we'll put that together by determining what those custom cutoffs are going to be. So for membership, we're going to need a custom binning. So that is doing this weird formatting because it's centered. So let's make that left justified so we can see that. All right, so our bin names here are going to be the membership level, right? So here we're going to have bronze, and then we'll have silver, and then we'll have gold. So what we're going to need to do is put it on here. We're going to do custom binning based on spending 2021. All right, so we can look up here at the quintiles of spending and use that to guide us perhaps. So the reason that gave me an error is because I put a little minus sign to give it like a dash. And I like that idea to kind of make like a fake bullet in a sense. So I'm going to go back and put a little single quote and then a minus so that it will actually put that in there. All right, so now I'm going to need the bin min and the bin max. And this is going to be our little lookup table for creating our tiered membership. You know, you can get all fancy on these if you want, play around just to build your skills, you know, make the tops of the tables bold, you know, center this, just, you know, however you want to, you know, work on your Excel skills, it's going to always pay off. All right, so we want to come up with what are these custom cutoffs. And like I said, we may want to look at the quintiles and use that perhaps in some sense. Another thing you could do is we could go over here and look at the clean data. I copied it here, so I'm going to look at it here, spending 2021, and I'm just going to do a histogram. Just kind of the way my brain works is I want to kind of see what I'm looking at in this data. So I have this data and I'm going to cut this. So I'm going to cut this out of here and I'm going to move it here. And hopefully that gives me just a little place where I can kind of look at, see what's going on. So what I'm seeing is there's some data that's much lower in a sense. And this, if you recall, where is when we're going to be doing a sensitivity analysis. So we're going to hold off on doing these variables differently in each one of the subsets until we know we need to use it and do it. I just don't want you guys to have triple the amount of work right now. So first, we're just going to do the anything with spending 2020. We're just going to do it right now without remembering that we have to do a sensitivity analysis. But we will come back full circle and look at that again later. But for right now, we are somewhat going to ignore these 4 outliers. And we'll look at this data and we say, well, it looks like just on this piece here, as if we're really can see maybe what would be a way to bin. So if we want to do that, we can think about different ways to do this. I just made I'm just stretching by finding the shaping, different shaped arrows when I hover over the corners in Excel on my chart so that I can see the upper bounds of these intervals. So it looks like if I perhaps wanted to make the bronze have a cutoff at 1433, right? That would put us in this middle bin right here. And what looks like a, you know, except for the outliers, it looks fairly symmetrical and fairly, I mean, there's a little bit of off, but it's not too far. So maybe we can use this to make some bins. So if that were the case, it looks like the bin max, if I use that, would be the 1433. And then the only other one I really need to do, right, because the bin min, I'm going to go say, well, you want to be a member in the bronze. We could put a lower cutoff if we wanted. So you know, if you're not coming in and spending very much money, maybe you don't get to be in a membership level at all. So we could start this one at 1305. And again, this is a little bit up to you, but because we're going to be proposing this to Catherine Hill. She asked us to propose something, and so that's what we're going to do based on the data. And we'll let her push back if she wants to change it. But we're going to say, okay, these first two kind of histogram bars is what I'm using for bronze. Silver, I'm going to say the next two. And that ends up here at 1561. And then, and if you remember, because these are right inclusive, this 1305 was not actually in this bin. It's just the number at the top of the previous bin, but that's okay. Okay. And if we look at spending, it is all the way out to the penny. So when we do these bins, we probably need to be going out to the penny on them. So let's go ahead and format this whole thing by going home and formatting this as money. And it's automatically giving us to the penny. So that's great news. And then the last one is going to be the maximum in our data. So this is saying it's 1689.00 in this bin. So that's fine. We can use that, or we can confirm, we can say equals the max and of all our spending data, right? So go over here to spending and we'll select that. And we get that it's 1638.69. So this bin was a little bigger than the maximum in the data, and that's fine. There's nothing beyond that anyway. So either way, okay, so I will let you continue using that to create membership assignments in here. Okay. The next one that we're looking at is the race reduction. So race reduction is where we want to, and if we remind ourselves again by looking at the analysis plan, the only ones we want are Black, Hispanic, white, or other. Okay, so there's several ways we can logically program this. So one way we can do this is we can say, we can use the if function that, if you recall, the structure for an if function is equals if, and you have a logical test, and then you're going to put what to do if it's true and what to do if it's false. Right now, this is just notes to self. This is not actual coding. If true, this is where we're going to substitute what we do there, and then what we do if false. Okay. So for the logical test, we have to test something about the value of race. And I don't know if I can get them all to fit. Let's see, we can get race and just barely. If I get C on the left over here, I got the column C and I got the function here where I'm trying to build it. So whoops, I don't want that. Let me get rid of that. Okay, so the test I want to say is if this is Black, white, or Hispanic, I wanted to say Black, white, or Hispanic. Now I can do this with a nested test. So let me do this, like, first of all, I'm going to do it the really long way, and then I'm going to do it again, giving us the same answer, but in a much shorter code. And it's just a way to think about this. If you have something like this, you have to do. So I could say if Black, so I'm going to point to this cell over here where race is, and I'm going to say equals, and I'm going to put quotes, Black. And I have to make sure I spell it exactly right, capitalizing what to do. So if that is Black, if that's true, then what I want this to say is just whatever's here. So just give it back to me. If it's Black, go ahead and put it. If it's not, well, then I need to say, now I'm going to nest an if. This is the nested if approach. Then I'm going to say, well, if what's there is white, then I'm just gonna get that value right back. If it's not black and it's not white, then what do you do if that's false? Well, then I'm gonna say, well, if C2 is equal to Hispanic. All right, so now then I want it to just give me back whatever is in that cell. Now I'm purposely building the structure of this function so I can copy it down and it will give me the right answers. Okay. If you recall, these are the only three we actually want to keep, and we're going to lump everybody else all together into other. All right, so switching back over to the Excel, here I'm just going to put in quotes, other. Okay. Now I have to make sure I have enough closing parentheses. I'm closing the most inner if. Now I'm going to close the second if, and now I have the outer if. So now that I have all of these conditions selected, and I want to make sure you follow the logic on that, you'll see that this should come back black. All right. And I want to kind of compare these right next to each other. So I'm going to show you another thing you can do when you're working within a worksheet. You can actually select a range of columns. So let's say I select all these columns here. I can right click and hide them. So you notice this now goes from C to X, but I can see right next to each other if I'm getting the right answer. All right, so let me double click this formula and see if it worked. All right, so white, black, that's all working. Asian went to other, that looks good. Unknown went to other. Pacific Islander went to other. So we did successfully program a new variable that only has 4 race categories: black, white, Hispanic, or other. All right, now I'm going to show you another way to program the exact same thing, but does not have all this long, complicated nested ifs, which sometimes can lead to errors, right? Where you have to like figure out where's your missing parentheses or what happened. Okay, so the other way to do this is to kind of flip the logic around. And maybe what we could say, if you're not black, so there's this function called not. So if you're not black, so is C3 equal to black? If that's false, or is C3 equal to white, or is C3 equal to Hispanic, right? So if it's going to evaluate the inside question, is C3 black? And if it says false, then it's going to turn that to true, because it's going to take, and when you put the word not in front of a logical test, it's going to give you the opposite. So if this comes out to be a true, putting the word not in front of it will turn it into a false. And if what's inside is false, putting the word not in front of it will turn it into a true. Okay, so that's how that function works. And now let's talk through this logic together. If what's in the race cell C3 is not black, if that's true, and it's not white, and that's true, and not Hispanic, and that's true, then we're going to say other. Now the question is, we have to say all of these at the same time have to be true. So we're going to also wrap this with the function and. So it's going to be not black and whatever comes after the comma, not white and not Hispanic. And we're going to close the parentheses on that. All right, so this is another way. Maybe you don't like this. Maybe you prefer the nested if, long chain of nested ifs, and that's fine. This is just a way of saying, okay, if all of these are true, it's not, the cell location is not black and not white and not Hispanic, then we're going to say they're other. Otherwise, we're just going to put what's there. Okay, now because there was only one if, we are able to get away with doing this just by closing one parentheses. All right, now I can double click this and copy this formula down, and we can confirm that it is also working correctly. Right, and then there's yet another way to do this. All right, notice I had to write not in front of all these. If they're not black, and if that cell location is not black and not white and not Hispanic, then they'd be other. There is a logical, for those of you who remember your logic, alternative way to do this. We can say, we can add or, and let me get rid of this part in the front of here. So we can say if the cell is black or C4 is white. So C4 is black or C4 is white or C4 is Hispanic. So if any of those are true, then we're going to keep them, right? So if the cell is black, white, or Hispanic, then we're going to keep whatever's there. So if that's true, we're going to just keep C4. Otherwise, we are going to put other in that cell. Okay, so again, we are using the structure of an if statement that has an if, a test, what to do if it's true, and what to do if it's false. And we're kind of flipping this around a few different ways so you can kind of just learn whatever your brain's logic follows. And that I wanted to introduce you to some of these different functions like and, or, and not. Okay, so now that one worked. So it's because we checked, is this C4 right here black or white or Hispanic? And if any of those are true, then we're going to just copy whatever's there, and then otherwise it's going to be other. So let's just copy that formula down and confirm it works as well. All right, so when we go down here to, so everyone is copying over, but Asian did become other. Pacific Islander also switched to other, so this is working. Okay, so whichever one of those three options works for you, or maybe you even came up with another different way, and there are many variations on how to do this. All right, so let's say we did this, we're like, good, okay, how do I get all those columns back? Well, we're gonna do the bookends. We're gonna select C and X, because these are the two bookends. And I held down the shift key when I clicked on the top of column X, so that I'm inside this little narrow rectangle are all the columns between C and X. So I'm going to right click and choose unhide. And then I get them all back. Okay, so now I've done all of these. And now the only thing left are the dummy variables. All right, so the dummy variables, I'm gonna let you work on those. They are very straightforward applications of the if function as well. So for TV, I'll just do one for you. I would say this is equals if, remember you always either want a 0 or a 1, depending on if it's true or not. So I'm just gonna say if, whatever the channel was, if it equals TV, and I'm gonna put that in, gotta make sure I have the capitalization correct. And I have it in double quotes. If that's true, if whatever's on the channel is TV, I'm gonna put a 1 here. Otherwise, it's gonna get a 0. And now I have created a TV variable for channel. And if I just double click that little box, you'll see, and again, if you wanted to, you could hide all the columns in between just to put them next to each other. You can hide them and you'll see that wherever there is a TV, it is giving me a 1 and 0 otherwise. Okay, and then I can unhide these when I'm done. Okay, so that's how you want to proceed to create all the additional variables. The next thing we're going to want to do, once we've created all our additional variables, we'll read this in the analysis plan. It says, the following subsets of the analysis ready data set will be created. After the data has been cleaned and the new variables added, the analysis-ready data set to be used for further analysis would be called ARDS full. Okay, so if you recall, I told you that anytime you do any kind of index match, which is what we're going to be using all in here, we're going to want to make another copy of all this data. And so I'm going to go back and select all the data. Well, first of all, I guess I need to create a new worksheet. And let me see, maybe I can just do it all in once. I'm going to select the whole rectangle of data. I'm going to come down here to other, which after you do complete your work, you'll have numbers, zeros or ones in here. So I'm going to come all the way down to the bottom of my data. I'm going to get this big rectangle of data and I'm going to copy it. And I'll go ahead and add another sheet. And remember, this is where you want to paste just the numbers because we want to get away from all the embedded Excel functions in there. And we want just those values. So you'll be doing something like this. And this one is maybe what we can call the analysis ready data set. So I'm just going to abbreviate that here as ARDS. And this is the one that we said in the analysis plan that we would call analysis ready data set full. So now that I've done that, I'm going to want to go ahead and move our copy. So I want to make a copy of this. But I'm going to go and I want to put it in a new book because that's what I just got done reading, that I'm going to, once I have it all ready, I want to create a copy in its own book. So let me go in here and click new book. And so it's going to be a brand new Excel workbook that has only one tab. All right. And this is where we're going to kind of pick up our analysis from. We don't need all those other tabs in there. Okay. So I will, and actually let's go back and make sure we've done everything else that we said we needed to do. So after we do this, we're going to have our analysis ready data set. Then we are going to use that to create the millennials subset. Okay, so we have some conditions on the millennial subset. It's just based on birth dates, right? So we're able to filter this. So we are going to create the millennials. I'll make another copy of this. So let's just move our copy. I'm going to make a copy of it. Create a copy, and I'll move that to the end. And I'm going to call this millennials. And I think I abbreviated that to MILS. Okay, so this is going to be our millennials. And if we go back, let's go ahead and see what we need to filter to. Notice that birth date is no longer showing up as a date, and we need it to be. So we better go back to our ARDS full and change that to be a date. So we can go back in here and make that a date, and we can do the same thing. We could have done it at the beginning and then we would not have had to do it twice, but it slipped by me. Okay, so there we go. So let's say we want to filter this data that we currently have to millennials. So what we're going to do is go to data and put in our filter tab. Okay, so we can use now these drop down arrows and come in here and we can try selecting manually the dates that we need. So we want to only select dates between, so we want to exclude anything starting from January 1st, 2000. So maybe the better way to do this is to take out what we don't want. Okay, so we don't want anything after 2000. And on the other end, we want people who are born January 1st, 1982. So this could be like a long process, right? Because we got to go through all these years, all the way up to 1982. So that's one long way to do this. Another way to do it is we can use these date filters. Let's use a date filter and we're going to say between. Okay, if the date is after or equal to, let's say we want to say 1/1/1982, and is before or equal to, so we want to be before January 1st, 2000. That means we want to be on December 31st of 1999. And now we can say, okay. And now we have this filtered data.